So children, coming to organic chemistry, yesterday we have completed catenation and tetravalency, and we were discussing why it is called organic chemistry, etc., etc., all those things. Now, another important property of carbon today we are going to discuss allotropy. Allotropy. What is meant by allotropy? Children, allotropy definition. Allotropy means existence of same element in different forms. Existence of same element in different forms is called allotropy. Okay, children, existence of same element in different forms. Carbon is present in so many forms, children, we have. So that existence of same element in different forms is called allotropy. Then you will get out, sir, only carbon will show this property, any other. So many elements will show this property, children. So many elements. Okay. So suppose phosphorus is there, white phosphorus is there, yellow phosphorus is there. Suppose sulfur is there. Okay, flowers of sulfur is there, mu sulfur is there. Different. So many elements have got this property, allotropy. But because we are discussing organic chemistry, we are going to discuss allotropy of carbon. The carbon compounds are of two types. The carbon allotropes, the allotropes, existence of same element in different forms. There are of two forms. One is crystalline form. Crystalline means they have some geometrical shape. Another one is amorphous. They don't have any shape. Amorphous means no shape. Amorphous means what? No shape. And here they have some geometrical shape. Okay, children? Right now. They have shape, here no shape. That's all, children. Now under crystalline we'll see diamond is there. Graphite is there. C60 is there. C60 is Buckminster, fullurene. Buckminster is scientist name who invented, discovered that. Fullurene is C60 formula. Amorphous, you have so many other forms. Coal is there. Coke is there. Lampblack is there. Charcoal is there. Under charcoal again, three varieties are there, children. Sugar charcoal is there. Bone charcoal is there. Wood charcoal is there. Okay, anything. So many varieties are there, children. Okay, what is charcoal means? If you heat sugar in absence of air, the ash which you get is sugar charcoal. If you heat bone in absence of air, the ash which you get is called bone charcoal. If you heat wood in absence of air, that is called wood charcoal. And heating anything in absence of air is called famously as destructive distillation. What is destructive distillation? Means heating in absence of air or a limited supply of air. Okay, if you heat sugar in limited supply of air, you will get sugar charcoal. Bones in limited supply of air, you will get bone charcoal, and wood in limited supply of air, then wood charcoal. So these are amorphous and crystalline forms of carbon. See, same carbon, whether it is diamond, whether it is graphite, whether it is coal, whether you take diamond and whether you take ordinary coal which you burn in your houses, they both have carbon, but see the difference. Diamond shines millions of rupees, thousands, lakhs of rupees, whereas coal for 10 rupees you get. See the difference. Same element, difference is there. Same element, that is the difference. So what is allotropy means? Existence of same element in different forms is called allotropy. Two forms are there: crystalline and amorphous. Crystalline forms are diamond, graphite, and fullurene. Amorphous forms are coal, coke, lampblack, charcoal, lampblack, coal, coke, lampblack, charcoal, tar, wood charcoal. Oh, so many things are there. Okay, all of them are different allotropic forms of carbon. Okay, you should be in a position to identify what are the allotropes. Among them, our question for 10th boards regularly they are giving is what is the difference between diamond and graphite? They are asking. What are the difference between diamond and graphite? Let's check. Okay, children. Now all of you understood what is allotropy. What is allotropy, children? Existence of same element in different forms is called allotropy. How many we studied? We studied diamond. We studied graphite. We studied fullurene. We studied coal. We studied coke. We studied charcoal. We studied lampblack. We studied, and all this comes under crystalline form, and all this comes under amorphous forms. Crystalline means they have some shape, and amorphous means no shape. That's all, no geometrical shape. Okay. So like this is called allotropy. Now here, important question is, what are the differences between diamond and graphite? This is question, important question. Please mute your audio devices. What is the difference between diamond and graphite? Is an important question. Okay, channel first one. Diamond is very, very hard. In fact, hardest on the earth. Graphite is very, very, very soft. Why it is soft, I will tell you, don't worry. Diamond do not conduct electricity, do not conduct electricity, whereas graphite conducts electricity. Why? I will say again, don't worry, nobody else. And diamond is tetrahedral in shape, tetrahedral in shape. Graphite is hexagonal layer-like structures. Hexagonal layers will be there, hexagonal layers. And diamonds shine in original shape, they don't change. Okay. These are the important three differences between diamond and graphite. Okay, diamond is very hard, do not conduct electricity, and tetrahedral in shape. Tetrahedral, you know, children, like this. If it is possible, try to draw figure also in examination. Okay, this is diamond structure. Okay, one carbon is linking with four carbons, that only I called as tetravalence yesterday. And graphite, children, hexagonal in structure. Okay, what is the shape of graphite? I said hexagonal, children. 1 second, hexagonal structure. Hexagonal like this, children, I'm showing here. Like that, so many layers will be there. Like that, so many layers and so many different. Okay, so these are the major difference between diamond and graphite. 3 marks question: what are the difference between diamond and graphite? Means you should write it's hard, soft, do not conduct, conductor, tetrahedral, hexagonal, and shape. Draw figure. Try to draw figure. Now, important question is why graphite is soft? 1 mark question. Why graphite is soft? Because graphite is in layers. So many layers are present. So many layers. All layers have weak forces between them. Graphite is in layers. Layers are held by weak van der Waals forces. Layers are held by weak van der Waals forces. They slide over each other. Okay, and hence it is very soft. Because it is very soft, graphite is often used as lubricant. Okay, children, try to understand. Children, there are so many layers like this one above other, one above layers are there. These layers will slide above each other. This much sliding which I am showing with my hands, it won't occur that much, children, but they slide. Because of that slide and the weak van der Waals forces which are present between the layers, this is very, very, very soft. And the soft nature, because of that, it is often used as lubricant, like oils and grease. How we use it, graphite is also used as lubricant. So in exam, if they ask why graphite is soft, we should write graphite is in layer structure. One point. Layers are, all the layers are held by weak forces, van der Waals forces. If you forget van der Waals spelling, just write weak forces. These layers, because of weak forces, slide over each other, and therefore it is very soft. Hence, often it is used as lubricant. All the 5 points you should cover. Last time I was saying graphite is present in layers. Layers are held by weak forces. Layers slide over each other. It is very soft. Hence, it is used as lubricant. This is soft. And why it conducts electricity? Why it conducts electricity? Normally, one carbon, I told you, it should bond with 4 carbons, or normally tetravalence, you know, children, 4 bonds it should form. No? With 3 carbons, it will form. 1 electron is left freely. This free electron, one free electron is present. One free electron is present. Okay, this free electron is responsible for conduction of current. This free electron is responsible for conduction of current. Hence, graphite is often used as electrode in electrolysis, and our cathode will be there. No, graphite also we can use because it conducts electricity. Okay, why it conducts electricity in exam? If they ask for 1 mark, you should say it has one free electron which is responsible for conduction of electricity, hence it is used as electrode. Or they may ask like this also, why it is used as electrode? Because it conducts electricity, as it has one free electron, it is a good conductor of electricity, hence it is used as electrode. Everything is same, children. This 2 reasons many times they asked in exam. Why it is soft? Because of layers. Why it is soft? Because of layers. Layers are held by weak forces and they slide over each other. Hence it is soft and often used as lubricant. And why it conducts electricity? Because it has one free electron. Free electron is responsible for conduction of electricity, and because it conducts electricity, it is often used as electrode. What is electrode? Anode or cathode. If you connect to positive terminal, it is anode. If you connect it to negative terminal, it is cathode. You can use it as anything. And graphite is very soft. It is also often used in pencil leads. Pencil lead is made up of graphite. Okay. So all of you try to understand, children. These are the difference between diamond and graphite, and graphite exclusively uses also. So what all I told children today, what all I told everything about allotropy of carbon. Okay. So I told allotropy. What is allotropy? Existence of same element in different forms. What are two forms? Crystalline and amorphous. What are crystalline forms? Diamond, graphite, fullurene. And what are the amorphous forms? Coal, coke, lampblack, charcoal. Charcoal, again, three varieties: sugar, bone, and wood charcoal. Okay. How you will get all these things? By destructive distillation. What is destructive distillation? Heating in absence of air. Cover the vessel and heat it. Okay, you will get some ash, some wood gases, some liquid, all that you will have to collect in another one. And in this, I told the difference between diamond and graphite. Diamond is very hard, this is soft. This is not conduct electricity, this conduct electricity. This is tetrahedral, this is hexagonal. Shape and shape also you should draw. Okay, shape also you should draw. Now, why it is soft I said? Because it is in layers. All layers slide over each other because they have weak forces. Hence, it is very soft. As it is soft, it is often used as lubricant. I told you. Okay, and why it conducts electricity? Because every carbon unites with only three other carbons. One free electron is present. One free electron is responsible for conduction of current. Hence, it is often used as electrode. Electrode means it can be anode or it can be cathode. These are the allotropy topic. If I ask allotropy, everything you should write about all these things. Okay. So here, small discussion about destructive distillation, children. Only small discussion I will do. It is not there in your board exams because anyway we are discussing. I will tell small about destructive distillation, children. Suppose wood is there. Try to understand. Suppose wood is there, children. This is wood. They will take a closed vessel. Inside they will keep wood, and they will start heating in absence of air. If you close it, and here they will put a pipe, and they will connect it to another chamber. Okay, children. Now, when you are heating this, what happens? Wood will liberate. Try to understand. Wood will liberate wood gas. Wood gas will come and also it liberate wood tar. Wood tar also will come and get settled here. And charcoal. Charcoal is collected here only. So wood will liberate three things. Charcoal, which is present here only. Charcoal will be present here only. Wood gas and wood tar gets collected here. Okay, and wood tar means liquid here. And here one more chamber will be filled, and wood tar goes and gets collected. Wood gas will be collected in this wood gas. Okay, like this. Same bone also, same sugar also, like this. This is by destructive distillation of wood and bone and charcoal. Destructive distillation means heating in absence of air. All these things they won't be given in textbook, children, but I'm saying. Why I'm saying means it is there in source of energy lesson, children. In source of energy, what they are telling means one question they are asking: why charcoal is better than coal? Why charcoal is better than coal? Because coal and charcoal both can be used as fuel, children. This also can be used as fuel, this also can be used as fuel. But it liberates a lot of pollution. This won't liberate. Why it won't liberate? Because already gases are collected and liquid is gone, children. All harmful substances, I told you will collect in other thing. Only charcoal is present. And here it is low calorific value. It has high calorific value, means it liberates large amounts of heat. Charcoal. And it is more poisonous because more gases will come, it is less poisonous. And here it burns without flames. Means complete combustion will occur, children. Blue flame will occur. Here blue flame will get because complete combustion, ash liberation will be less. So charcoal is better than coal. Exam they may ask this question also. Its calorific value is high. It burns without flames and it liberates less pollution. Its calorific value is high. What is calorific value? Amount of energy it is giving. Okay, it's very high, and its pollution is less, and it burns without flames. Flames won't come much like it as you get in coal. Okay, children, this is about allotropy. Okay, children, everything you understood allotropy. So definition is existence of same element in different forms. Existence of same element in different forms is called as allotropy. Okay, children, understood? Existence of same element in different forms is called allotropy. Okay, children. I hope you all understood. This is yesterday we studied catenation and catenation. Catenation and tetravalency. Today it was about allotropy. Tomorrow we discuss about one more topic in organic chemistry. Thank you, children.